about points? How many letters do we use to name a point?
2. 1.
1. We've learned about lines. How many letters do we use to name a line?
2.
2. What about planes?
2. 3.
3. What about segments?
2.
What about rays?
2.
2. Okay. Those are all the things that we have learned. That we can see, we can draw them, we can write about them. We're learning a new one today. I know. It's called an angle. You've probably at least heard the word before. But an angle is a set of points that consists of 2 different rays that have the same end point. So let me draw that out for you. Here's what an angle is. Jordan, focus. We have a ray. That's a ray. We draw another ray off that same endpoint. I just drew an angle. This is an angle. Okay? I want you to think of like hands on a clock. That they move, the angles get bigger. It's an angle. Okay?
I just draw an angle.
These rays, we call them the sides of the angle. Those rays are the sides of the angle. And the end point that they share, that yellow point, is called the vertex. Shh, focus in the back. You've probably heard the word vertex before, maybe in algebra. But when you see vertex, think V. This is the point of your V. It's the point on your angle that makes the V shape. Okay? Just like with everything else we've talked about, we're going to talk about how to name angles. There are 3 options, technically 4, for naming angles. We can use just the vertex. So for this one, what is the vertex? B. So I can write that letter down, point B, and then I can use an angle symbol. Here's your angle symbol. It almost looks like an L. It almost looks like a less than sign. It's basically a less than sign that's like flat, like this, or like this. So we could call this angle B, or, Jordan,
No,
stop it, just put it there. There we go.
We're on YouTube, Jordan.
Or we can use the other points and write our angle by tracing it out. So that what that means is I want you, Jordan, turn around. I want you, as I trace out this angle, to tell me out loud what letters I'm crossing. Are we ready?
Yes. A. B. C.
I can name my angle A, B, C. Just like that. I can do it the other way. Talk C.
B. A.
C, B, A. What do we notice about these two? What's the same?
The angle.
The angle symbol and?
B.
And B. B is in the middle.
Oh.
If you name your angle with 3 letters, that middle letter has to be the vertex. Always. Okay, that middle letter is the vertex. The vertex is like the most important part of our angle. That's how we name it always. There's another option for naming angles that you'll see on your homework. Sometimes there's like a little number in here. Sometimes there's a number. If there's a number, we can name the angle with the number. So I could also call this angle 1 if there was a number 1 there. So you have 3 options. Just the vertex, just the number, or tracing it out. Okay? So we use really 1 or 3 letters. Questions on naming angles. Okay. It gets a little bit tricky because I'm going to trace out an angle. I want you to tell me what the vertex is.
B.
It's B. Okay, what if I trace out a different angle? What's my vertex there? B. What about this angle? What's my vertex? It's coming in a second. B. Were those 3 angles the same? No, they weren't. I traced 3 different little alligators. It gets tricky if we called every single one of those angle B. So if we have something like this or like this, where there's more than one angle that has that vertex, we have to use all 3 points. So instead of calling this angle B, I have to call it A, B, C. Okay? What would I call that angle that I just highlighted?
ABF.
Angle ABF. Perfect. What about this orange angle? EBC. Perfect. I think we're getting the gist. Questions on naming angles?
That is a 2.
Where?
No.
This?
Yes.
It's an E. I write my E's curly, and sometimes I'm lazy and they kind of get a little messy.
North face.
Okay, that's how we name angles. There's a few more things that we can talk about with angles. The inside and the outside, essentially. The interior of the angle is all the points between your 2 rays. It's inside the alligator mouth. It's what it's eating. The outside, the exterior, is all the points outside your alligator mouth, okay? So that's these 2 definitions. Interior, the points in between those 2 rays. And exterior, the points outside those 2 rays. What's up?
Can I have the rest here, please?
Yes, go ahead. Okay, so let's do some examples. We're going to name the vertex and the sides of each angle. This first one, number 1, what's my vertex? F. So I'm just going to say point F. Okay, when I name my sides, the sides of an angle are rays. So I always have to write them as rays. Start there. Write the rays down. What is the end point of both of those rays? F. So F has to go first for both of them.
I'd give it back.
Okay, don't throw it again.
Alright.
And then I use the other point on that ray to name it. So what would I call this?
FG.
Yeah, ray FG for this side. What would I call the other side? FE. Perfect. Notice how they both start with the vertex. Those F's and this F. Everything revolves around the vertex for angles. The next one looks a little weird. This is an angle that we've taken and we've just flattened it. It's now straight. What's the vertex of this angle, do we think? L. I agree. Vertex is L. What's one of my sides? LK. And what am I missing if I just write LK down? I need the ray symbol. Ray LK. What other ray is a side? LM. Perfect. Questions on identifying parts of an angle. We're going to skip that third example. Let's go to writing names of angles again.
90 degrees, 45 degrees, 30.
Very, pretty good. We're going to talk about that later, but very good. This first angle, how could I name it? Someone give me one way. What's the vertex? I could call it angle O. What else could I call it if I trace it this way?
TOS.
Angle TOS.
TSP.
Not TSP. What else could I call it? Angle, if I trace it the other way.
SOT.
SOT. Perfect. Do number 6 on your own or with the people around you. Give me all 3 ways you can name it. I want 3 ways.
Angle X. W X Y. Screw you.
What? What do you want? Where are you seeing an X or a W or a Y?
There's the XWY.
That's what I was wondering. This one right here. Do number 6.
Oh, number 6. Oh, I did number 5. So
Number 5 is fine
I'm on
too.
that page still.
Whatever. Do one of these 2. I don't care. Whichever one you're feeling.
R angle QRS angle SRT.
Yeah, perfect. So, one way, if I used one letter to name this angle, what letter do I have to use? R, the vertex. Okay? If I trace it out Boys in the back, we gotta focus. If I trace it out this way from Q to R to S, how would I name it? QRS. And what's the other way if I go reverse order? SRQ. Perfect. Okay, grab a fidget and then sit down. Okay. Questions on naming angles. That's part 1. Okay. Do we remember how we have something called the ruler postulate that tells us that we can measure segments? Do we remember learning about that? Okay. Just like with segments, we have something that we can use to measure angles and give a number for each angle. Has anyone seen this shape before?
Protractor.
Protractor. This is what we use to measure angles. Here's how you use it. Listen. Here's how you use it. This is a big version. But you take it, this arrow at the bottom, you line up with your vertex. And you make sure your line is all the way at the bottom. This bottom piece represents 0. We see this 0 here on this on the white protractor.
Yeah.
Represents 0. Then we look at where our angle ends. What 2 numbers does it end at? 40 and 140. You pick the number. This is going to sound confusing until we do the next example, but here's what I want you to do. Pick a number over here, bottom or top, doesn't matter. Let's go with the bottom one. Then we pick the bottom number over here, 140, and we subtract them. What's 140 minus 0? 140. This is a 140 degree angle. We measure all angles. We measure angles in, that's not where that's supposed to go, in degrees. So what we did here is we said 0, 140, we subtracted them, and this angle was 140 degrees. If I see another ball rolling or in the air, the fidgets will go away for forever.
No.
What if I
It wasn't
throw the
me.
ball back
It was
to
not me.
Huh?
What if I throw that ball back to Jordan?
We're not throwing anything.
What if I
It
pull
wasn't
it back?
me.
You don't have to. That's the thing.
What if I can't?
Should I do that? Okay.
It was
So, shh. This degree symbol is not degrees Fahrenheit. It's not degrees Celsius. It's completely new. Okay? It's the numbers on this protractor are in degrees. The way we write the measure of an angle is M for measure. You two, separate yourselves. We can't do it.
He's jumping.
Separate yourselves.
I'm writing with
One of you move to the high top. I don't care who.
I want Jordan over here.
One of you move to the high top.
I can't. Miss Cruz, I can hear you.
Okay, then figure it out.
Yes, ma'am.
Okay. What'd you say?
I'll help you edit this part out on YouTube.
Oh, awesome.
Please don't.
Okay, listen.
It's funny.
Listen. We're almost done. The way we abbreviate angles for the measure, we say M for measure, and then we name the angle. What's the angle? What's the name of this angle? What's one name?
140.
Angle O or AOB. So I would say the measure of angle AOB is equal to 140 degrees. Very similar to when we were talking about a segment with the segment on top versus the length of that segment with no segment on top. Same kind of vibe. Instead of getting rid of a segment, we're adding an M once we want to start talking about measure. Okay? There's a little bit of a difference. Okay, let's do an example. There's one nearly identical to this on your homework.
What if we do this?
Huh?
When do we get to do that?
After we get through the notes, if we can.
I'm confused. We're doing like these, like the example ABC, right?
Uh-huh.
What's like the M before like the GH?
That's for measure. So we're not just looking at angle GHK, we're finding the measure. So if there's an M in front of it, your answer should be a number with the degree symbol. Okay? So we're looking for GHK. Here it is, GHK. Let's look at our numbers. Over here I see a 0. I'm going to use it. If I use the top one over here, I have to use the top one over here. What's the top number over here? 125. Perfect. And then I subtract them. What's 0 minus 125 or 125 minus 0? 125. If you get a negative number, that's okay. Just make it positive. We won't deal with any negative angles, so just make it positive, okay? Do the same thing for JHL.
90.
Here's JHL. Jordan, how'd you get 90?
90 minus 0.
Perfect. 90 and 0 are the numbers that it goes with. So 90 degrees.
Is the next one 30?
Then we do LHK.
35.
Yeah, 35. How'd you get 35? What two numbers?
90 minus 125.
I agree. 125 and 90. Subtract them. You get 35 degrees. Questions?
I did also think that looked like an 85.
Oh, come on.
Why is it
If
back?
we slow down, that would be a problem.
Oh,
Any questions on how to use?
Show me yourself, really.
Any questions on how to use a protractor?
It's like, do a thing, Yui.
Yes.
do we have to put that little degree thing?
Yes. If you don't put that little degree circle symbol, I will take points off.
Uh-oh.
35 what? 35 cows? 35 inches? I don't know. You tell me.
What if we put
Degrees.
instead of that little dot?
No, put the dot. Put the circle. Okay. Charlie mentioned this earlier. He was a bit ahead of the game. Charlie, you said an angle was a right angle. How did you know?
Because it's a perfect 90 degree.
It's a perfect 90-degree angle.
Dude, shut up, Tracy.
Guys, figure it out. We're almost done. I know it's Friday. But a 90-degree angle is called a right angle. So when the measure is 90 degrees, it's a right angle. And that is straight up and straight horizontal.
Is there multiple answers to these angles?
No, like each column's only going to have one picture.
Oh, okay.
Okay. Does anyone know, maybe from algebra, how we label this as a 90-degree angle? There's a little box in the corner. Perfect. Right, like that. So anytime you see that box, you think 90 degrees.
I know what a cute is.
What's a cute?
I don't know.
You're cute.
Does anyone know what a cute is? Here's the way I think of it. It's a cute little angle less than 90. Yeah, a cute. It's a cute little angle. So this is when your measure is less than 90, but it's still positive. We won't talk about negative values for angle measures, so it's greater than 0. It's a positive number, but it's less than 90. So your measure's between 0 and 90. It could look something like this. That's probably like 30, 35 degrees. If acute is a cute little angle, what do we think obtuse is? A big angle, more than 90.
Big boy angle.
So an obtuse angle is when your measure is more than 90, but less than 180. We will never talk about angles over 180 degrees. So that's an obtuse angle. It's a little bit bigger. Can look something like that. The last one is a straight angle. It's when it's exactly 180 degrees. So your straight angles and your right angles are your special kind of angles. It's not just acute or obtuse. It's a little bit special. And a straight angle that's 180 degrees makes a line. If we look at our protractor, 0 to 180 goes on that line. So a straight angle makes a line.
Are we done?
No. But we can speed through this last part. I believe in us.
I'm sorry for laughing.
Questions on these definitions. Let's practice it. This first one, the measure of angle D is 90 degrees. Is it acute, obtuse, right, or straight?
Right.
Right. 20-degree angle, what do we think?
Cute.
It's acute. It's a cute little angle. It's tiny. What about 180?
Straight.
Straight. What about 108?
Obtuse.
Obtuse. It's bigger than 90, and it's not 180.
Obtuse?
Perfect. Huh?
I said obtuse.
Obtuse. This will be part of your test. There will be questions like this on your test that have you classify angles. Okay?
Hey, that's going to be fun.
Okay. Another definition we have. Do we remember congruent segments?
Yes.
Congruent segments have the same what?
Length.
Length. We have congruent angles too. What do we think congruent angles will have? The same,
Degree or.
yeah, degree measure. They have the same measure.
Ow, my pencil.
They have the same measure. And for segments, we use like a little hash mark like that. Do you remember these hash marks?
Yes.
For angles, we use arcs instead. These little arcs. These red arcs on the inside of your angle. Same measure. Same measure. And we can kind of do the same thing. One arc. These show us that these two angles are congruent. But if you have two arcs, these two angles would be congruent, but not congruent to your one arc. So we use like the number of hash marks and arc marks to determine what's congruent and what's not congruent. So anytime we see congruent symbols, we should be setting these things equal to each other. Their measures are equal.
Oh, when they do that little line with it.
So anytime you see a hash mark or these little arcs on the inside of your angle, you're going to be setting something equal to something else.
Alright.
Let's do an example. It says that these two angles are congruent. How do you think we would find the measure of x, y, z? We set them equal to each other. We have to solve for x first. But these two measures are going to be the same. They're going to be equal. So 6x minus 43 is equal to 3x plus 17. Now we solve for x. What should we do? Plus 43, and what else can we do? Subtract 3x, perfect. We get 3x is equal to 60.
Figured it out.
What'd you get, Charlie, for x?
X equals 20.
I agree. Divide by 3. X is equal to 20. But then we pause.
8.
3.
That's a 3. But then we pause for a second. And we would do this on our homework. We actually look at the question and see what it's asking. Is this asking us to find x?
Oh.
No. What's it asking us to find?
Degree.
The measure of angle XYZ. So what do I need to do with this 20? Not divide it, but
Add it. Subtract it. Move it.
plug it in. Plug it in.
Oh, flippity.
The measure of angle XYZ is equal to 3x, but x was 20. So 3 times 20 plus 17.
37.
Not 37.
77.
77. 77 what?
Degrees.
Degrees. Perfect. Anytime you see that M, you better have degrees next to it. Questions on that one?
No, ma'am.
Okay. One more postulate and then we're done. This one's pretty easy. Do we remember what happens if we wanted to find the length of this whole segment? What would we do? 5 plus 2, and we would get 7. Same thing works for angles. Small angles plus small angle or part plus part will equal your whole angle. So what that means is this degree measure plus this degree measure is going to equal your whole angle ABC. You add them together to get the whole thing. Are we good over there?
Yes, he's just standing up every time he looks back.
Because
Just hang tight. Let's get through it. Okay.
And now Will's hitting me. It's like rain.
Will.
Okay. Listen.
Others.
What's special about these angles? Listen, they are right next to each other. They share the same vertex and they share a side. This blue ray, they have to share. They have to be right next to each other. Okay? So let's do some examples. This first one. If I wanted to find the measure of this whole angle, ACB, what do you think I would do?
Add
You add, what do you get?
125.
125 what?
Degree.
Degrees. 100 plus 25, 125. The second one, we need the big angle, QTS. What do we get?
160.
160. How'd you get that, Jordan?
120 plus 40.
120 plus 40. Exactly.
110. Bro.
Hold on. One thing at a time. The next one, what two numbers should we add? 20 and 90 to get this big angle. And yeah, we get 110. Okay. Anytime you see a little arc like this, that's referring to the whole angle. And that whole angle has the measure 110 degrees. So that means 110 is my whole thing is equal to part plus, what's my other part? 70 is going to be my answer, but what's the other part that I know? 40. My 110 degree angle, this yellow one, has to be equal to WZX plus XZY, so plus 40. What do we end up getting for that last part? 70 degrees. Are you good?
He's pushing my desk every time I do something.
Don't push his desk. You were pushing it with your foot.
Your foot, yeah.
You were pushing it before. Don't push his
Okay,
desk.
I was pushing it before, but he wasn't in it.
Okay, but don't push it now. Okay,
This class is so funny.
the next one. Again, that arc goes with the 90. So this whole angle is 90. A piece of it is 55. What's the other piece?
40.
Not 35. 90 minus 55. 35. And then the last one, the whole thing is 180. This piece is 100. What's my other piece? 180 is my whole thing. 100 is my other piece. Yep, 80 for this one. 180 minus 100. We have one more example, team, and then we're done. One more, and then we're done.
I'm not a team. I work alone.
You're a team. We're all a team.
Whoa, whoa, cut out.
One more, and then we're done. This one, we're going to do the same stuff, but we have algebra now. It says the measure of angle DGF, so your entire angle, is 126 degrees. What's one of the parts of that angle? 3x plus 4. So that part plus the other part. What's the other part? Help me out.
7x plus 2.
7x plus 2 has to be equal to my whole thing, equal to 126.
126 degrees.
Well, yeah, 126 degrees. So 126 is equal to, on the right, how many x's do I have? 3 plus 7,
10.
so 10x.
Plus 6.
Yeah, and 4 plus 2 is 6. What's my next step?
Minus 6.
Minus 6, I get 120 is equal to 10x. Now what?
Divide by 10.
And we get x is equal to
12.
12. We divided by 10. Divide by 10.
Now I gotta.
Yeah, was my question asking for x? No, it's asking for DGE. I'm going to highlight it. DGE and FGE. So let's do DGE first. The measure of angle DGE is equal to, what do you think I do here? It's 7x plus 2, but I have x. What should I do? Plug in.
7 times 12 plus 2.
Perfect. 7 times 12 plus 2. Anyone know what that gives you? 7
I
times
do.
12 is 84 plus 2? 86. 86 what?
7.
Degrees.
Degrees. Okay.
No, my.
Now I know that this one is 86. Do I need to plug in x to find the other one?
No.
My whole thing's 126. This one's 86. What does my other one have to be?
40.
40. It has to add to 86. Jordan, you're killing me today, man. This one has to be 40. 40 plus 86 is 126. So you could plug it back in. or you can use your angle addition postulate. Questions on any of those? Okay, before you start your homework, I want to make sure that we can handle it. Around the room, I want you to do those 4 problems with yourself or with a partner.
I want a whiteboard.
You can do them on a whiteboard. Show me when you're done, and then you have homework time. These are very, very similar to homework and test problems. Very similar.
It fell out of my hand.
Uh-huh.
No.
Yes.
Do it.
Uh-huh.